So I'll share my screen. Okay. So as we all know, like, so today in this session, like we'll be going through what these containers are and then what Docker is actually, before actually going with further topics like of Kubernetes. So as we already discussed, like this is planned for like next 2 weeks, like daily 1 hour, and then it's just like a hands-on session kind of thing. So we'll practice in parallel, like along with me. Yeah. So I have like few questions. So I think like many of you are from different backgrounds. Like I see almost like 20 people joined. Like, so I just wanted to know the experience of you guys. Like, so how many of you are from the development background, or how many of you are going to be like into the DevOps role kind of thing? Like, any rough estimate? Like,
Good afternoon, Pavan. I'm from development background, Venkata.
okay, hi Venkata. So you're from I9, right?
Yes, yes, Java background.
Okay, okay, nice. Okay. Yeah, so I assume like so at most like 50% of the people like who joined, so they are from the development background, and some of them are uh, going to be like into the DevOps teams or something like that, right? Okay. Uh, yeah. So do you guys have like any prior experience, like anyone who joined the call? Like, so do you have any prior experience with the Docker, or did you ever make use of this Docker in the past? Or at least an idea of what Docker is actually.
Yes, sir. No.
Okay. Uh,
No,
okay. That's
no.
fine. Yes, go on. Okay. So let's get started. So basically, like I assume, like, so are you guys are familiar with virtual machines, right?
Yes, sir. No.
So
Yes.
a virtual machine is nothing but like basically like in the past we initial days like we used to have like this is almost like 25 years 30 years back like so we used to have like physical machines like just like our laptops like we used to have big machines and then on those machines they used to act like servers and on those machines like we used to deploy applications like web applications and we or any applications. So after that, like the virtualization concept, so it kicked off, and then we were able to create, like we were able to create have like a big server, and then on top of that particular server, like we used to have like multiple virtual machines created, and each of these machines, so they were allocated to people, and each of us, like so instead of having like one physical machine, like so we can have like a virtual machine created and you can work on that particular virtual machine. So it's just isolated, and then you'll have your own desktop kind of setup over there, right? Um, so after that, like once after these virtual machines, so now like the concept of containers. So this is more evolving, and then so people are using like these containers a lot. Like so, these are like I don't say like these are like alternatives for the virtual machines, but for in the from the perspective of like application development and then application deployment, like so these containers they play a crucial role when compared to these virtual machines. Okay. So let's understand like so this is just like a the Docker like so it's just like an open source platform which was actually developed by Docker. Docker is the company name. Okay, so this can be used by developers and then system administrators. Like they can build applications and then they can pack these applications and then deploy using these Docker containers. Okay, so so it's not just for the deployment purpose or other activities. Like so, this can be used even for the local development also. Like so, if you want to install like any specific software like Redis, like so, and if you are on Windows machine, so you don't have access to the Redis. So Redis is just like another software, so which is not present on the Windows. Like, but using Docker, like you can still make use of these Redis. So this is just an high level. So we'll just go deep into what Docker is actually. Okay. So the challenge, like, when we are actually deploying these applications, like, so we have a lot of challenges. So let's assume that like we are actually trying to deploy our application, which has like a static website kind of thing, and then it needs to interact, or if we want to develop a dynamic website, and if we want to interact with a database, or so if we want to interact with any of these queues, so these queues are nothing but like these are some softwares like. Um, for then these softwares together they form a stack, and in order to deploy these items, like, so there were like multiple items you can see. So this is, you can see the static website, you can see this Nginx like 1.5. Okay, and then here like you see Python 3.0. So whereas like Postgres, it has like multiple versions. So even if you see Python, so it is 2.7, and nowadays like we also have Python 3.0. So um, as a developer, like initially we start developing these applications on our local machines, right? So once we start these applications, so did anyone face an issue with in the development such that like, so you tried to develop an application in one version, like, so maybe it's like Nginx 1.5 or Python 2.7, and then so when your friend or when your colleague, so he's actually trying to run the same application on their machine. So did you ever face an issue such that like the code is actually running on your machine, but it is not running on their machine, something like that? Did anyone face that particular issue?
Yes, Pavan.
Mhm. So what was the challenge like that you faced, Venkata?
It's related to more or actually jar issues, version issues.
Mhm.
Whether we're building on a one machine that we are moving to environment across or any other machine, I usually it related to some jar versions, jar mismatches, or something low level. That is.
Mhm.
So when coming to the high level, it should be an environment specific that something is missing, a configuration level or that kind of thing. We are always face such kind of challenges.
Yeah, exactly. So let's say like I have Node version, or I'm predominantly work on .NET. So let's say like I have .NET Core installed on my machine, and then so I started developing an application using this .NET Core. Okay, so I committed all my code to the GitHub, and one of my teammates, like he doesn't have like .NET Core installed on his machine. So he tried to download the codes, and when he is executing this application, so it is obviously failing because he doesn't have like this .NET Core installed, or there might be a version conflicts or something like that. Okay, so these are the basic problems like in every developer, like they always face. Okay, so whenever like we are shipping these applications, and when the stack is increasing, like, so in this case, like you can see like there are multiple softwares, like uh, different softwares, and there are 100% chances like there can be like version mismatch, or any conflicts arising because of these versions, or any softwares missing on their machines. Okay, so if just assume that if we want to develop this, deploy the same application onto different environments, like a development VM, QA server, and then production clusters or production machines. So how difficult it would be, like, right? So we need to install all these softwares and make sure that like all these machines they have the same version of the software installed or something like that. All right. So do you think like this is a big problem?
Obviously, it is a big problem.
Yeah, so obviously like, it's a big problem. So as the product size grows, so we might be introducing like more and more technologies, and then so more and more things, right? So maintaining like consistency across different environments. So obviously like it's a difficult thing, like so installing this software. So for this, like, so Docker comes into the rescue to some extent. Okay, and we'll see like so how Docker actually rescues us. Okay, so this is the challenge, like you understood, right? Yeah, so as I was mentioning, like some of these software names, so it's just like I just wanted to give a description of what these softwares are. Nginx is like a web server. Like if you want to host or your application, like you just use this Nginx. So queues are nothing but like there are many queues like Redis, RabbitMQ, and then Azure was all these things. Okay. Uh, okay. So let's see like what are all what's the problem statement and then how. So let's say like we are actually deploying developing a static website. So we, as mentioned, like so we need an Nginx server to serve these static pages, right? So we have like if we want to develop this static website, so we have this Nginx. This is supposed to be installed on the machines like where we are running this software. Like so we have like multiple environments like development VM, QA, prod, and then this is like a cluster of machines, production servers. And if we want to deploy this on a public cloud, so this is cloud. You can see like so in order to deploy a single static website, so you need to have 1, 2, 3, 4, 5, 6, 7, almost like 7 different environments like we need to track. And then so installing the same version of Nginx on, we need to make sure that we install the same version of Nginx on all these servers, all these environments. All right. So for this, like in order to solve some of these complexities, like this is where the term container it actually comes into picture. So this is the word like the Docker is actually using. Like so, we'll see like what a container is actually. Okay. So basically, like you guys are actually familiar with like shipping containers, right?
Yes.
Yeah. So for example, if we want to ship a car or if we want to ship a barrel of oil or any of the goods, like so whatever the goods like we want to ship across the globe, so we are basically using like shipping containers. Okay. So and these shipping containers like they are handled by different environments. Like so we can place these shipping containers on a truck or we can operate them using train or cranes. They can be shipped via using a ship. All right. So all whatever might be the product like input. So we are not worried about them. Like so we are simply like as an end user, like so we are simply putting these products into a shipping container and then we are shipping them. And on the other end, like so what they're actually doing. So they are again like they are not worried about what is the product that is present inside this shipping container. So they're simply there are ways, standard ways to handle all these shipping containers, right? So it's just like a shipping container always you can see like so its size is always fixed like most of the shipping containers, so it has a specific characteristics. All right. So whatever the container you see, they're all of same size and then they have like same weight or something like that, and they can be handled at any port, shipping ports. Right. So you can just think of it like so whatever the input is, whatever the product you are actually trying to ship, so it's it is basically like so we are not worried about the product, like so we are just worried about how we transport them. And then so we place all these products like any of these products into a container and then they are handled by different means on the other side. Okay. So can we apply a similar concept to our software development? So you can see like so each of these goods can be considered as like different products, different softwares. Like so it can be a static website or it can be like a database, like in a database, Postgres database, or it can be like uh, Java application or a Tomcat server or whatever it might be. So if we want to pack them all together and then so if we abstract the details to the end user and then if we are able to ship it on, if we are able to deploy it onto multiple environments like QA, stays, production, whatever it might be, like the developer's machine. So it would be easy, right? So pack all these softwares in a container and then so the end user like so he'll just simply run this container like so without actually knowing what is inside the container. So that will be easy, right?
Yes, then.
So
Yes.
all so Sandhya, like so you're able to understand like so what's the use of this Docker now?
Yes,
And
sir.
yeah, so Sandhya and others in the team, like so your team, like so you're yeah, so did you find the relationship between like what's the problem we are facing nowadays? Like what so you're able to understand that? especially with the development and then the deployment process. Like, so since you are actually starting, since your team is actually starting with this, like the Docker containerization and then DevOps role. So I just wanted to make sure that like you understand more your team.
Yes, Pav.
So you understood the problem statement, right? So what's the problem we are facing nowadays and how it can be tackled? Like, so this is the same analogy which like we can actually apply for our deployments and then our day-to-day development tasks. So any questions till now?
No, Pavan, no.
Okay, yeah. Um, Yeah, so these are the possibilities. So for example, if you want to ship a barrel, ship like all these petroleum barrels, like, so what's the best way like we choose? So if we want to ship it on a train or if we want it to operate on using a crane or all these transportation vehicles. So we can simply pack all these barrels in a container and then any of this train or ship or whatever it might be, so it can easily pick them up, right? So because they're all well aware they are all meant for this, like, so these containers, these things, like, okay. So the same way, like if we want to ship cars from one country to another country, so again, like we'll be using containers with coffee beans or whatever it might be. So we'll be using like same containers. Okay, so it's a standard way, like containerization. So we in India, like we also have like a company called as Container Corporation of India. Like so they deal with these containers in India. So you can understand the uses of these containers, how predominantly like we use these containers. Okay. So for everything, like we can use these containers. Okay. So this is the traditional way of like shipping. Like, so they used to have like, so if you have a coffee bean bag, like, so you need some equipment to handle those bags, like coffee bean bags. Like if you have a car, like, so you need to have a separate equipment to handle these cars. But nowadays, if you see, so everything is actually containerized, like everything is being transported via containers. Some of these metrics, like, so there are almost like 200 million containers that are being delivered like per year. Okay. So can we apply the same logic for our development, like for the development purposes? Obviously, yes. So we can use like Docker containers for actually shipping all the code and then hosting all these applications like end to end. Okay. So the same thing, like, so you can just have this static website like Nginx installed on a container. And then along with that, like we can also have like user database, queues, everything, like they are packed together. And then we can run it on the development machine, QA machine, or whatever it might be. Okay. So when we are actually packing, like we pack it with a specific version of software. So this way, like we can actually prevent the problems of software version conflicts or something like that, right? So do you guys agree with me?
Yes, son.
Okay.
Yes, sir.
So this is the main motto of Docker, like, so build once, run anywhere. Okay, so when you're actually building this particular Docker container, so as a developer, like what we need to do is like, so we need to build this application. So it's usually the role, the responsibility of a developer and SREs together, like to create these containers and then deploying them. Okay, so what the developer does is like, so he's the one like who is aware of all these things, right? So he's the one like who decides which version of the Nginx should be used and then which version of the database or what database is supposed to be used, right? So when we build like once, we create a container once, and this can be used anywhere. Like, so whether it is like a Raspberry Pi or Linux machine or Windows machine or Ubuntu machine, so you can still use this particular container without any worry. Okay, so this is just a comparison between the physical containers and then I mean Docker containers. So content agnostic. So whatever we are not worried about what the content we are placing in this physical container. So it can be like coffee beans, or we can actually put like cars. The same way like we encapsulate any payload into the Docker. Okay, so the same analog. Like, so hardware agnostics, like, so these containers, if you see, like, so they have a standard shape, and then they can be used, I mean, so all the equipment like that are used to handle these containers, so they're same across the world. So the same way, like in the Docker also, like, so once we install Docker on a particular virtual machine or a physical machine, so we can simply run any of these containers without any issue. Okay. So content isolation. So basically, like, so if we have like 100 containers which we want to ship from one city to another city across the world. So in one container, we might have like cars. In another container, we might have bananas or something like that. So, and we are not supposed to be worried about what content we are actually delivering. And then each of these containers can have their individual content. All right. The same way, like when it comes to Docker, so it's just like resource isolation, and then so each container will have its own network, and it also has like its own IP address. Okay, so high efficient, and then separation of duties, like, so these things are just like some of the common things. And Docker is supported by many of these cloud platforms. Like, so it is supported by AWS, DigitalOcean, Docker, Google, and then Microsoft Azure or GCP. Like, so wherever you go, like, so they all support like Docker containers. Okay. So you can just build a container on your developer machine, and you can just deploy it on any of these services, like without any issues. Okay, so we saw the motto, like, so what's the motto of Docker? Build once and then run anywhere. So we are not supposed to be worried about any missing dependencies or packages. So as Venkata was actually mentioning, like, so sometimes like he faced a problem with these jar files. So version conflicts between these jar files. So maybe on my machine, like I have Python 2.7, whereas like my colleague, he has like for Python 3.0. Okay, so these two, like Python 2.7 and 3.0, are completely syntactically they are different to great extent. So they are not backward compatible even. So obviously, like, so the code which I built on my machine, so it would definitely fail on his machine. But if we go with Docker, so whenever like I create a container, so I can just specify like use Python 2.7 or something like that. And then so when he's running the same container on his machine, so obviously, like, it will first install like Python 2.7, and then it will try to copy the code and then run the code. Next thing, like run each app in its own isolated container. So let's say like if this is if the on this laptop, like I can run like n number of containers. Okay, so and each of these containers, like it is not something like, so if in one container, like I can have Python 2.7, and then on another container, like I can have like a Python 3.0 installed. Okay, and it doesn't cause any issues. But if we don't use containers, and if I want to have different versions of a software, like, so for example, like if I want to have Java, uh, maybe the latest version is 8, and I also wanted to have like Java 10 installed. Okay, so let's say like I wanted to run two different applications. So one is running on Java 8 and the other one is running on Java 10. So obviously, like, it is difficult for me to have like two different versions installed, and then I need to configure, and there are like a lot of configurations that come into picture, right? But when it comes to Docker containers, so that's not the case. Like, so one container can actually run Java 8, and then the another container, it can actually run Java 10. Okay. So it is basically used for automate testing, and then integration packaging, like with anything you can script. Like, so basically for the deployment, like on your developer machine itself, like you can have like all these predefined stuffs created. Like, so for example, like if you want to install different softwares like Python, Java, so in the Docker file itself, like you can just specify all your requirements. Like, so first install Java, then next install Python, and copy some of these bin files or jar files or download these jar files from the internet. You can just specify all these steps in the development at the development type itself, and then so you can create these containers and images. Okay. So reduces or eliminate concerns about compatibility on different platforms. So for example, like, so you spent almost like 6 months of your time developing an application on your development environment. Okay. So now in the development environment, and then the QA tests they're all passed. So after 6 months, like you decided to deploy this particular application, like onto the production cluster. Like let's say like you wanted to deploy this application onto 100 machines. 100 different machines. So there are like, let's assume that there are 10 different softwares this particular application is making use of. So what you need to do, so you need to make sure that you have the same version of these softwares installed across the board, like on 100 of these instances. All right. And also you need to make sure that like, so all this, I mean, so there is a backward compatibility or any compatibility issues. So you need to make sure like, so all of these machines, so they're supposed to run on Ubuntu 16.0 or something like that. So they need to have specific software. So just imagine like, so if you want to make sure that like, so all these 100 machines are in sync, so how difficult it is, like it would be always obviously difficult, right? Do you agree with me?
Yeah, it's
Yes,
bit
sir.
difficult actually.
Yes. Yeah. So traditionally, like back when we are not using any of these clouds, so at that time, like, so it was quite difficult. But nowadays, like even with these virtual machines, like all these cloud providers, so they have some templates, like instance templates. Okay, so you can create an instance template once, and then you can just replicate you can create all these 100 instances, virtual machines from this instance template. But still, like we'll have some difficulties. Okay. So it's cheap, zero penalty containers to deploy services, a VM without the overhead of a VM. So if you want to go ahead with like a virtual machine, so obviously like you'll have some difficulties. Like, so you need to install this OS on all of these machines, right? So any questions till now?
No,
No
no.
problem.
Okay.
No problem.
Okay, so now let's see like how these Docker containers actually run. Okay, so before actually showing this, so I wanted to show something else. Yeah, so did you ever work on any virtual machines like? Um, so Sandhya, like, did you ever work on any of these virtual machines?
No problem. Just we have created, but we didn't work on any virtual machine.
Okay, so but I think like you worked on some of these virtual machines. So whenever like you used to work with the client application, so you used to connect to that particular machine, right? So you never connected to a virtual machine?
Yes, we connected.
Okay, so you connected to it, right, Raj? So how about you? Like, so then Naidu.
No, no.
So you never use like virtual machine. So
No.
virtual machine is nothing but like, so it's just like a, so it's just like so we have like our physical machines like laptops, right? The same way, like in the virtual machine, so we'll have a guest OS, like, so you can have like, so basically like it's let's say like if I wanted to create a virtual machines or something like that, like from scratch without using any cloud technologies. So what we do, so we have like an server rack in our office, right? So we can actually build it, we can purchase a big server, and then in this server like we can actually install like hypervisor, like so this is a software like that was provided by Microsoft. Okay, so you can just install this hypervisor, and then there like you can actually create like multiple virtual machines, like I'll try to see. So this is my physical machine, right? So this is my laptop. So if I want to create like any virtual machine, so what I need to do, so I can simply quick create. So it will ask you for an operating system. So which operating system I want to install, like we can install like any of these operating systems. Okay. So let's say like I want to select this version. Mm, So see, you can actually see, so this is actually downloading this OS like Ubuntu OS. So I don't want to do that right now. Okay, so when I just try to create a virtual machine, so it is asking me to select like which operating system I want to install, and then it is actually downloading this particular Ubuntu onto my machine. So what is happening behind the scenes? So we have this is my physical machine, right? Um, so it is something like this. So this is my laptop. Okay. So on top of my laptop, like I'll have something like Hyper-V. So there are like multiple softwares like so Hyper-V, VMware, and they all support like virtual machines, help us in creating virtual machines. So this is Hyper-V. And on top of it, like so what we do, so we can install like multiple OSs. So if I want to create like one Ubuntu machine and one Linux machine, one Windows machine, VM, so I can create like multiple machines like so with different OSs installed. Okay, so I can have like a number of virtual machines created on my laptop. Okay, and how do I connect to this virtual machine? So here, like you can actually connect. So you'll be provided with a virtual machine, and then you can simply double click on it, and then it will try to load that particular virtual machine. So it's just like once you log in into the virtual machine, it is just like our host machine. Okay. So you can directly log in into any of these virtual machines, and then it's just like your PC, Windows machine or something like that. So what's the overhead we are seeing over here? Like, so this is my laptop, right? This is my laptop, and this is like Hyper-V or VMware. And this is my OS. Okay, so these are all virtual machines. So first of all, like, can someone tell me like, so what's the advantage of this? What is the advantage with these virtual machines, like creating virtual machines on your laptop?
One physical mission, we can use it more physical mission, more virtual mission.
Yeah, exactly. So let's say, like I'm working on multiple projects. So I predominantly work on .NET related projects. So this is my Windows machine. So I can actually install all these softwares like Visual Studio, .NET, and whatnot. So I can simply work on my laptop. But let's say now I wanted to work on some of another project like so, and that particular team. So they are using like Ubuntu, and then they are using like PHP or Python or so whatever might be like. So they are using like Ubuntu as their base OS. Okay. So if I continue the development on the Windows machine, so obviously like I need to tweak a lot. So I need to make sure that in order to make this particular application which is running on Ubuntu to run on my Windows machine, so I have to tweak a lot. Okay. Uh, and this happens with all the developers. Like let's say like we have 50 developers who are actually multitasking and working on different projects. So obviously like it's difficult for them. Like so we need to tweak it, and then we are supposed to make sure that like we don't actually break the real code which is running on the Ubuntu machine. We don't commit any wrong things. All right. So just to avoid that, what I'll be doing, so I'll just have this VMware or Hyper-V installed, and then on top of it, like this is my Windows machine, right? So I'll just create like a new Ubuntu machine. Okay. So inside this Ubuntu machine, like again, this is just this virtual machine is again like another computer, right? So I'll make sure that like I have all those softwares that are required by that particular project installed on this virtual machine and carry on with my development work. Okay. So do you see the advantage of this virtual machine?
Yes, Pavan.
Yeah. Sandhya, like, what do you say? Like, so do you understand like what a virtual machine, your team, like, so when I say Sandhya, it is not only you, but anyone from your team, like. So did you understand the uses of like these virtual machines?
Pavan, can you repeat once again? I didn't
No,
understand.
no. Okay, so you didn't understand. Yeah, that's cool. So I'll repeat it, no issues, but don't hesitate to ask me. Okay,
Okay,
not
Pavan.
just for you, like anyone like who just joined. Okay, so you understood, like this is my laptop. Okay, so I'm giving this session on my laptop. So I'm a .NET developer, you know that, right? So I work with all these Microsoft products, like especially like IIS, Visual Studio, and .NET Framework. Okay, so these .NET technologies, so they work only on Windows machines, right? So now let's say like I have this requirement to work on another project. Like I also need to work on another project, which is actually based out of like, which is actually developed based on like Ubuntu OS. Ubuntu is nothing but like Linux, flavor of
Okay.
Linux.
Mm.
Okay. Um, so or you can take the vice versa. So since when you purchase a laptop, okay, so you can your laptop has like Ubuntu, so you are a seasonal Ubuntu developer, okay. But later, like so, you are supposed to work on some .NET project, and you cannot run a .NET project directly, like a .NET framework directly on Ubuntu machine, okay. So you can run it only on this Windows machine. So now you have two options. One, so you can purchase like another laptop and you can put these two laptops side by side and then parallelly code all the .NET projects. Like you can work on the other laptop and then all the Ubuntu related projects. So you can work on the another laptop. Okay, so that is one option. So obviously it is not cost effective. So you need to purchase like two different laptops.
Mm.
So it is not effective. So that is where like these virtual machines they come into picture. Like so basically like this Hyper-V. So this is a Microsoft related one. Or if you want to go with like other versions, like you have VMware, and there are also other softwares that are supported by other companies like Oracle and many other companies. Okay, Cisco and all these companies. So what you can actually do, so in this case, like I have Hyper-V installed on my machine. Okay, so and virtualization enabled. So what I do, so I'll simply go to this Hyper-V and then I can simply create a new virtual machine.
Okay.
Okay. So it is asking when I'm creating a virtual machine. So it is just asking me which OS you want. So since I want to work on Ubuntu project, so obviously like I'll select like Ubuntu.
Sir,
Okay.
virtual machine here mean container or
No, so this is just a virtual machine. Still like we didn't go to the containers.
okay.
So yeah, this is just like a plain virtual machine. Okay. So obviously, like so here, like I can select this Ubuntu machine and then I'll create a virtual machine over here. Okay. So when I'm creating this virtual machine, what it is doing, so it is downloading this Ubuntu,
Okay.
Ubuntu 18.4. So this is another OS, just like Windows OS. Ubuntu is another OS.
Okay.
Okay. So it is downloading this Ubuntu and then so it will try to install Ubuntu here.
Mm.
Okay, so it will create a virtual machine. So when you want to connect to that particular virtual machine, so obviously like you'll see this list like virtual machine list. Like I don't have one over here right now. So you can simply double click on it and then it will open the interface. So that is one way of connecting. And another way is like so if you want to connect to a remote virtual machine.
Okay.
So here, like this is remote desktop connection. So you can simply provide the IP address of the virtual machine and then you can just connect to this. So this will not connect. So I need to, this is some related to the clients, so I cannot actually connect to it right now. So once you connect to this, so it will open this interface. So I can just show you. Yeah. So it will just open the interface and then it looks like the similar thing. Like so, if it is like a Ubuntu or Linux ones, like it will provide you the console. Okay. And if it is like a Windows virtual machine, so you'll have the same interface over there.
Okay.
Okay. So it's just like a computer inside your computer.
Okay.
You got it, right?
Yes, Pavan.
Yeah.
Now I understand.
So the same way, like we can create any number of virtual machines. Obviously, like the RAM, and then since these virtual machines use this base laptop's RAM and the hardware, okay. So there will be a restriction, but if your RAM supports, like you can create those many machines over here, virtual machines. Okay, so you can have like one Windows machine, one Ubuntu virtual machine, and then one Linux machine, and different machines you can have. So that is what I'm just trying to explain. Like, so this is your hardware. This can be a laptop or a server. Okay. So on top of it, like you'll have this virtualization software. It can be like VMware or Hyper-V. So using this Hyper-V or VMware, like you're again installing the OS. So you're installing Ubuntu, Windows, or whatever it might be, right? So you're installing an OS completely. Okay.
Okay.
So this laptop or this server also has an OS, if you see.
Okay.
Okay. But still, again, like when we are creating these virtual machines, so we are installing the respective OS which we want. Okay. So it's clear, right?
Yes, Pavan.
So now what you can do, so from your laptop, like you can simply connect to this particular machine, virtual machine. And again, it's just like another computer, right? So you can do whatever you want. Like you can connect to the internet and then fetch the latest code and then run that particular Ubuntu application on this OS, this Ubuntu machine. So the same way like Windows machine and other machines. Okay, so this is all the virtualization and then all these virtual machines. Okay, so one of the drawbacks with these virtual machines, one of the advantages with these virtual machines is, so with single hardware, like physical hardware, like you're able to create like multiple machines, multiple virtual machines, and they're all isolated. Okay, so maybe like they can actually share this hardware, like this hard disk and then this RAM, but in a way like they're all isolated. So let's say like you have you created a folder or you copied a movie onto this particular OS onto this virtual machine one. So you cannot actually play this movie or the software on the second machine. Okay, so this is again isolated. You understood, right? So they act as like individual computers until and unless like you copy or share the files. So you'll not be able to access or access the processes that are running on one virtual machine in another one. They're all isolated. You got it, right?
Yeah.
But the drawback with this virtualization on the virtual machines is, so you need to install this host OS on all of these machines. Okay, so and OS is nothing but like it's an heavy one, heavy thing. Like, so if you want to install like a Windows Server 2016, or if you want to install like an Ubuntu full version, so obviously like, so you're consuming more and more resources of this laptop. Like all these OSs and these virtual machines, they're running on this laptop itself, right? So they'll consume these resources, these laptops resources. So when you have like four different virtual machines and each of these virtual machine has its own OS, so obviously like, so it will have some impact on this laptop, right? On this hardware. You see that, right? So any questions like others? Hmm. So it's clear, or any questions, or actually like you didn't understand anything?
Yeah, Pawan, I have a small question.
Yeah, tell me, sure.
So yeah, we created these virtual machines on top of the physical machine, right?
Hmm.
So and you said the virtual machines are isolated from each other.
Yeah.
So it will be isolated from the base laptop also.
Yeah, so they are isolated from the base laptop. For example, like you are trying to install Java. Okay, so your application. So you are working on three different applications, and then these three different applications. So they need different Java versions. Let's assume. Okay, so on the base machine, like you might have like Java 8. Okay, and then in the virtual machine, like you can have this Java 12 installed, and another machine like you can have this Java 12 installed on Ubuntu machine. So you can have another machine with Java 10 installed on a Windows machine. Okay. So they don't actually collide, like, so they're all isolated, even from the base host machine. All the processes running in this OS, so they're isolated from the host machine also.
Okay, so they only share the RAM and space, but not the files kind of things.
Exactly. So it will ask you for the sources, like so.
Yeah, while creating the VMs, we need to specify how much space we need to provide.
Yeah, so when you're creating this VMs, so it will actually ask, so before you begin, specify name and location, the name of the virtual machine, specific generations, 32-bit OS or 64-bit OS or other things. So you can actually assign the memory. So you want it to be like 1 GB RAM machine or 10 GB. So but it should actually contain only the lesser amount of my RAM. So for example, my laptop, so it is 32 GB RAM one. So I can just divide it like, no. So you can
So it
configure
should
the
be, yeah, it should be less than the physical laptop, right?
physical machine. Yeah, it should be always less than the physical machine.
Okay.
So if we want one more VM, already all the RAM is allocated to different VMs, and now we want another virtual machine, so we cannot do that.
So in a way, like you cannot. So for example, like I wanted to create two different virtual machines. So my laptop's RAM is like 32 GB. So if I wanted to create like another two different virtual machines with 16 GB and 16 GB, okay. So I can create them. So I can create these two machines with 16 GB RAM, okay. But at a time, like you'll not be able to run these two machines. Okay, because the
Okay.
first machine is allocating like 16 GB RAM, and when you start the second machine, so you'll not have any RAM left to the host machine, right? To the laptop.
Yeah. Right.
So you
So
can,
we will have to free some RAM for host machine also.
yeah. So
We cannot completely divide that to VMs.
yeah, exactly. So it is something like you're on top of your laptop, like your host machine. So you have these installed, right? So in a way, like so they are coordinated via this VMware or Hyper-V. Okay. So you need to have some memory allocated to the host machine also.
Yeah, right. So it is also running in the background.
Mhm.
Yeah.
Yeah. So the same way, like you can have this networking configured, like, okay, so if you want like one virtual machine to be accessible to internet or and stop the other one from being accessed from outside, so you can all configure that up. Okay. So you can also create like virtual hard disks. Okay. So it specify the amount of size like you wanted for these hard disks. Okay. So now you're clear about these virtual machines, right?
Yes, Pavan.
Okay. So now what the drawback what we are saying is, so each of these virtual machines, so it should have its own OS, and then obviously like it is an overhead. So if you want to have like Windows or Ubuntu is again like lightweight when compared to Windows OS. Okay. So if you want to have like two different virtual machines containing like Windows OS, so obviously like it's an extra overhead. Okay. So to avoid that, and what's the advantage that we saw? So isolation is the advantage that we saw with these virtual machines. So if we are able to achieve the same isolation without installing all these OSs, so obviously that is like a boon, right? So it helps us a lot. So we can actually reduce this OS installation, complete OS installation, and that is a saver. You agree with me or not?
Yes.
Yes, Pawan.
So that is where like the containerization and Docker come into picture. Okay, so now I'll show you the architecture of this thing. Like I'll draw another one. So this is my host machine. Okay. So on top of it, on top of my host machine, so I'll have like, so I have this host OS. Okay. So, and once you have this host OS, so what I'll do, so I'll have some binaries or processes created. Like, so for example, like these are the binaries. Uh, so these are the binaries that are required for running any of your applications. Okay. So these are like binaries. So this is not a complete OS, but these are some binaries that are required for running your applications. So these binaries are nothing but like, so for the successful running of an application, like so for the, so even if you see this Windows machine, so you'll have like many binaries installed, like so you actually see this Windows. So these are all like most of them, they are related to the Windows installation, OS installation, right? So for running this, even for the Docker also, like even though we don't actually need the complete OS to be installed, so we still need some basic binaries that are supposed to be present. Okay. So some binaries or Linux kernel. Okay. Oh, second. So on your laptop, like we are installing Docker. So on Docker, like, so again, like you can execute all these binaries or create instances, containers. So you can consider these like as a single container, like each of these items. So this way, like, so we eliminated this OS installation, right? So for example, like if you compare this thing, like, so we have the guest OS installed in each of these VMs, and on top of it, like, so you are having these application binaries that are required for running your application, and then you're running your applications, right? So now we are actually eliminating this need for this guest OS on this host machine, right? So we simply have the server like or the host machine, like this is my laptop, and then on my laptop, like I have this host OS, and I have like Docker installed on my host machine. So I have like Docker installed on my laptop, and using this Docker, like I'm able to create like multiple containers, and each of these containers, they have like binaries that are required. So if you want to create like an Ubuntu container, so you can just select like an Ubuntu base image, like Docker image. So it has like very limited. So if you want to install the complete OS, so it might actually take like 1.8 GB or 2 GB of your space, like for installing Ubuntu. But if you want to use the same container, like Ubuntu container, it's very lightweight. Like, so there are versions of Ubuntu containers, which obviously take like 100 MB or something like that. Okay. So base images, which take like just 100 MB. So it's always better to have like 100 MB when compared to 2 GB, right? So in on top of it, like you'll be installing you'll be running your applications. Okay. So if you compare these two, so and these are again these are isolated. So just like the advantage with these virtual machines is they all these virtual machines, they run in isolation. The same behavior can be achieved even using these Dockers, okay, Docker containers, okay. So all these applications, the application running in this particular container, so it is isolated from this application running on another container, okay. So you can have like Java 8 installed on this particular app1 container, and you can have Java 10 installed on this app2 container. So it doesn't actually mess up and then create any problem. Okay. You understood, right?
Yes, Pavan.
So that is the advantage with Docker. Like so, and this is the base architecture of a Docker also. Okay, so the Docker container, like you'll have the base container. So even here, like you still need the OS running, like so, but it is very minimal OS. Like so, if you take like Ubuntu as a base container, so it will copy only all those Ubuntu files which are required, like bare minimal things. Like okay, so it doesn't actually install the entire operating system. Okay. So you'll have Ubuntu, or if it is like a Windows Server container, so you'll still have like Windows Server OS present, like, but it is just like a minimal one. Okay, so you'll have this kernel, like which is nothing but like a Linux kernel or something like that, and on top of it, like you can have like multiple containers. So you can see this is a Debian container, and it has like Java and Tomcat installed. So this is an Ubuntu container. Ubuntu is OS, and then it has like MySQL and PHP installed. So this is an Alpine container with some static binaries. So it's clear, right? Or any questions?
Clear.
Okay. So how does this container actually work? So we actually saw how a virtual machine works. So basically, like when you create a virtual machine, so you need to have the software like Hyper-V software. And on top of this Hyper-V, like so what we are doing, like when we are creating a container, we are selecting the OS and then we are allocating this memory and then the hard disk space. And it is just creating a new virtual machine for us. Like so, but with Docker, like is this the case? So how the Docker actually work. And another advantage with these virtual machines is, so once I create this virtual machine and then I create I made a copy of all the softwares, like I installed all the softwares that were installed on my machine. Okay. So that were required for the project. So what I can actually do is, so I can actually export this virtual machine and then I can share this VDX file to all my team members. Okay. And what they need to do is like they can simply import this virtual machine. Import virtual machine. You can see this, right? So once I create this virtual machine, I can actually share it with you. So can we do the same thing with Docker? Yes, obviously, like we can actually do the same thing with Docker also. Like, so you can actually create these Docker images and then you can share these images to people in your team. And how does this actually work? So with this, like with this virtual machine, so it is simple. Like you can just right click on this virtual machine and then export this. Okay. So on your friend's laptop, like what you can do is like you can just import this virtual machine. So the same way with Docker, like we have multiple items. So Docker has the concept of like a Docker container container registry. So which is like Docker Hub. So if you see, so I also request you to create an account with Docker Hub today.
Okay.
Okay.
So Docker Hub. Okay, so this is my Docker Hub. So you can actually see these are all the images that I created in the past, like some 2 years back and some 2 months. But here, like you can see, so these are like different images that are available. Like, so if I want to have a Python image, so I can just go look here. Like, so you can also have your private registry. So this is my private one, right? So I can create like my private repository. So for example, like in your project, like you're using like Docker, okay? And that doesn't mean that like you upload your image into this public one, right? Public repository. So if you upload it to public repository, like anyone from outside of our company, like they can use this image. Right? So you can also have this private repositories where you can actually copy your images. So these are the terminologies. Like, so let me introduce some of these terminologies. Like, so this is the container registry. This is the Docker Hub. Okay, this is a container registry where you'll find all these content images. So the same way, like all these cloud providers like AWS or Google or whatever it might be, they have their own container registries also. Okay. So it's just like a place where you upload your code, your images, and anyone in your team, like your friends, they can simply download it from here. So this is container registry. So we have like a Docker file. So how this actual Docker works is, so for example, like you need to create a Docker. So let's say like I want to start a new application. So I want to create a static website which is deployed on which is served using this Nginx server. Okay. So how do I start? So what I need to do is like initially I need to create a Docker file. So the Docker file, I need to provide all these instructions. Okay. So when I want to start, as I mentioned, like I wanted to so I need to have an OS, right? So I need to specify like from which OS I wanted to pick. Like, so I can tell like from Ubuntu. In the next line, like I want to install Nginx. So I'll give all those commands required for installing those Nginx in this Docker file. So after that, like I wanted to copy the code from GitHub, like I want to fetch the code from GitHub and copy it onto this Docker container, Docker image. Okay, so I'll just specify all those instructions. So a Docker file is nothing but like it's the base thing, like where you'll specify all those instructions that you want to pack. Okay. So in the real time, like real time example, like the container, shipping container. So it's nothing but like in the Docker container, you'll take the container and inside this container, you'll place a car. You can actually place different items, right? And that so the same way, like we can have like multiple software instructions for installing like multiple softwares or something like that. So once you have this Docker file created, so what you do is you build that Docker file. Okay, when you build a Docker file, it will create an image from this Docker file. So once you have this image created, what you need to do is, so image is nothing but like it's just like from the file, like you're actually transforming it to an class or something like that. Okay, so once you build this image, so what you need to do is like you need to run that particular image. Okay, so when you run an image, like it will create a container. Okay, so once this container is created, so what you need to do is like you need to push this particular image onto Docker registry. So it can be like a private registry or public registry like Docker Hub or whatever it is. So once you push this particular image into Docker registry, so what all your friends, so instead of building this particular image from the Docker file, so they can simply execute a command like Docker run the image name that is present in the Docker container. Okay. So they'll be able to run the same version of this container. Okay. So you can run like n number of containers this way, like n number of copies of the same container. So this is just theoretical, but tomorrow, like I'll show it practically and you'll get more idea. Like, so, but does it make sense like theoretically? So first, like as a developer, I'm the starting person, right? So I'll be creating like a Docker file. I'll have all the instructions that are required for running my project. From this Docker file, I'll create an image. And from this image, like I'll create a container. And this container, I can push it to a Docker hub. So my friends, what they can do is like simply they can pull this particular image from the Docker registry and run the same container. So is it clear?
Yes, sir.
Yes, yes.
Clear, Pavan?
Sanjay? Yeah, so it's clear for your team, right?
Yes.
So next time, like I'll not call only Sandhya's name, so I'll make sure that I'll have a list of all the people like from your team, Sandhya. Yeah, so this is clear, right? Or any questions? I'll just wrap it up like for today. You can just ask me, like I'll have 5-10 minutes, 5 minutes, and then you can ask me if you have any questions.
My Docker file is a YAML file we write, right?
No, so Docker file is not an YAML file, so it's just like a text file. So where you specify these instructions, like I'll just show you like how a Docker file, sample Docker. So this is a Docker file, like you can just create a file with an extension of Docker. So you need to have Docker. It shouldn't have an extension of .txt or something like that. Okay. It is.
So this file contains only the commands to
Yeah, it just contains only the
create
commands.
Docker.
So this is the Docker file. So it has commands like, so I'm saying like I want to build this particular image from this container. So this is my base container. So where is this base container? So this is present somewhere in the Docker hub. Okay. So using this image, so I'm just trying to build this new image. Okay. So I'm just saying this run this APK so and so, so working directory. And these are all the commands. So that is the Docker file. It's not an YAML file. It's just like a file with an extension of Docker. It doesn't have an extension. We simply need to have it as Docker file.
Okay.
Okay. So others, like, any questions? So at least like you're able to, Sandhya and others, like, so you're able to get an idea, right? So what this Docker is and how, what's the difference between like a virtual machine and where exactly like these virtual machines come into picture, how they help us and how Docker is actually making our life more easy.
Yes, Pavan.
Yeah. Yes.
Okay. So if you don't have any questions, then we can wrap it up.
I don't have any questions.
Okay, then. Yeah. Thank you guys then. Bye.
Thank you.
Thank you, Pawan.
Okay. Thank you, Pavan.
Yeah, thank you.
Thank you.
Bye.